We now see integrals in which we need to use integration by parts more than once. So we're asked to find the following integral, the integral of x squared times sine of x. Well, looking at this, we can see that we're dealing with a product of two functions. Indeed, we have x squared, which is multiplying sine of x. So we'll use integration by parts, and remember the formula for that was the integral of u dash of x times v of x equals to u of x times v of x minus the integral of u of x times v dash of x. Now, looking at this integral, we'll choose x squared to be v of x and sine of x to be u dash of x. And the reason for this is because we can see that if we choose x squared as v of x, then in the second integral, in the integration by parts formula, that would turn into a simpler integral involving 2x rather than x squared. So let's go ahead and do that. We let u dash of x equal to sine of x, and v of x equals to x squared. Therefore, u of x equals to negative cosine of x, and v dash of x equals to 2x. So using integration by parts, we can write that this integral, x squared times sine of x, is equal to u of x times v of x, so that would be negative cosine of x times x squared, which is the same as negative x squared times cosine of x, minus the integral of u of x times v dash of x. So that's negative cosine of x times 2x, which is negative 2x times cosine of x. We can tidy this up a little, getting rid of these two negatives here, and we write this as negative x squared times cosine of x plus the integral of 2x times cosine of x. Now we see that this second integral is again a product of two functions, 2x and cosine of x. So once more, what we decide to do is to use integration by parts again. So focusing on this integral for a second, if we let u of x, or I should say u dash of x, be cosine of x, and we'll let v of x be 2x, that would lead us to the following. So u dash of x equals to cosine of x, and v of x equals to 2x, then u of x equals to sine of x, and v dash of x equals to 2. And so using integration by parts, we can write that this integral, boxed in black here, the integral of 2x times cosine of x, is equal to u of x times v of x, so that's sine of x times 2x, which is the same as 2x times sine of x, minus the integral of u of x times v dash of x, that's sine of x times 2, and that's the same as 2 times sine of x. And we can integrate that quite easily. Indeed, we can go ahead and state that this equals to 2x times sine of x minus the integral of 2 sine of x, which is negative 2 cosine of x. So writing that in parentheses, that's negative 2 cosine of x plus some constant c. And finally, we can state that this equals to 2x times sine of x plus 2 cosine of x plus c. Now that we've done that, we can go back to our initial result in blue and state that this equals to negative x squared times cosine of x plus the result we just found in black. That's 2x times sine of x plus 2 cosine of x plus a constant of integration, c. And there we go. We've just integrated the product of x squared times sine of x using integration by parts twice. Let's look at another example. As a second example, let's find the integral of 2x squared plus 1 times e of x. Now, once more, we can see that we're dealing with a product of two functions. Indeed, we have 2x squared plus 1, which is multiplying e of x. So we'll try solving this using integration by parts again. And let's just quickly remind ourselves of the formula. Remember, that was the integral of u dash of x times v of x equals to u of x times v of x minus the integral of u of x times v dash of x. Okay, so looking at our integral, we'll call v of x 2x squared plus 1, and the reason for that choice is because we know that in the formula, v dash of x, 2x squared plus 1 would turn into 4x, which definitely simplifies the integral a bit. On the other hand, e of x, which we'll call u dash of x, that one won't really change. Whether we integrate it or differentiate it, e of x just stays e of x. So let's go ahead and do that. We'll say let u dash of x equal to e of x, and therefore v of x equals to 2x squared plus 1. Therefore, u of x equals to e of x, no change there, and v dash of x will equal to 4x. And so using integration by parts, we can go ahead and write that the integral of 2x squared plus 1 times e of x equals to u of x times v of x, so that's 2x squared plus 1 times e of x, that's 2x squared plus 1 times e of x, minus the integral of u of x times v dash of x, so that's e of x times 4x, which is the same thing as 4x times e of x. Okay, now that we've done that, and focusing on our second integral here, we can see that once more we're dealing with a product of two functions. Indeed, we have 4x, which is multiplying e of x. So again, we'll use integration by parts. And in this case, we're going to call v of x 4x, and therefore u dash of x will be e of x. So let's go ahead. U dash of x equals to e of x, and v of x equals to 4x. Therefore, u of x equals to e of x, and v dash of x equals to 4. And so, if we focus on the integral boxed in green here, this can now be written as the integral of 4x e of x equals to, using integration by parts, u of x times v of x, so that's e of x times 4x, which is the same as 4x times e of x, minus the integral of u of x times v dash of x, so that's minus the integral of e of x times 4, which is the same as 4 times e of x. And we can take care of that integral quite easily, and we can go ahead and state that this is the same thing as 4x e of x minus 4e of x plus some constant c. Now that we know that, we can go ahead and state the final answer. And we can go ahead and say that the integral of 2x squared plus 1 is equal to 2x squared plus 1 times e of x minus all that result we have there in green. So minus, I'll write it all in parentheses, 4x times e of x minus 4e of x, and we'll write the c outside the parentheses, completely generic constant there. We now open up the parentheses to state our final answer, which is 2x squared plus 1 times e of x minus 4x e of x plus, careful of the sign there, plus 4 times e of x plus c. And we could go further, and we could factor this whole thing and say that this is equal to 2x squared plus 1 minus 4x plus 4 times e of x plus some constant c. And this can, of course, be simplified as 2x squared minus 4x plus 5 times e of x plus a constant of integration, c. and we're done. And so that's how we can use integration by parts successively to integrate more complicated functions which are products of two functions. Do keep in mind that we called the polynomial 2x squared plus 1 v of x, and that allows us to make sure, going back to our formula for integration by parts, that v dash of x is just a polynomial whose degree is less and less and less each time we use integration by parts. And there we have it. I hope that helps.